Hi everyone.
Hi everyone, thank you very much for coming to our presentation that is titled Solving the Challenges of Distributed Systems. We will be talking a little bit about Dapper and Spring Boot and the work that we have been doing in the last few months.
Yeah.
Again, let's get started. We have like just 50 minutes, like not even an hour, so we better get started.
Yeah, we better get started.
Yeah, so for this presentation, we want to talk a little bit about the challenges of building distributed systems, and we will not go into theory here. We will just basically say, distributed systems are complex, right? Like they are difficult to solve, they are difficult to create, they are difficult to maintain, and they are difficult to operate. So we wanted to talk about some solutions for those topics. If you are building distributed systems, you need to train all your team members to understand how they work. So scaling up teams and making sure that people actually have the right expertise to build these systems is quite complex. And finally, if you're working on the cloud-native space, you are seeing a lot of YAML, and we believe that the more YAML you have, the more like the developer productivity suffers, because you need to spend much more time configuring stuff and learning how to configure this instead of actually building your applications.
So I'm curious, how many of you like working with YAML? Raise your hand.
There you go. There you go. These are my people.
So maybe this is the wrong presentation, right?
No, I think that this is the right.
So how many of you think that it's a pain working with YAML?
It's the same people. It's the same people raising their hands.
Yeah, but that makes sense, right? Because
it's that's mixed feeling.
It's a love-hate relationship here with YAML.
There you go. And before we start, most of the content of the presentation is in this link. I wrote a blog post about it. Like it's 15 pages long. Yeah, it's pretty long, but like it goes deep into the details on how we are building this stuff. So let's get started. And what better way to start by talking about like a demo that we are going to present, right? So we created this very, very simple application. It's an application that is based on a Docker example that has been there for a long time already. How many people knows the example voting app from Docker? Because we have one person, two person. If you haven't been kind of like in the cloud native, it's not the cloud native space. If you have been looking at the Docker examples, which might be the case, this is a very well-known application that most people in the Docker space kind of like knows. And it basically works like this. You have a boat service where you're going to be casting boats, and those boats are going to be stored in a Redis instance, right, somewhere. There is a worker service that basically goes and reads these boats from the Redis database and creates a view that stores into a PostgreSQL database for consumption, so we can see the results live while you're boating. And then we extended this application with RabbitMQ, so we have kind of like an event-driven side of the application too. So every time that you receive a vote, we will be creating a RabbitMQ message that will be picked up by a dashboard that will be kind of like showing in real time again when the votes are coming in. So it's not showing the results, but just showing every vote that comes in. And what do you say if we just start using it?
Yeah, let's try it out.
Let's do it. So if you have your phone, if you can scan that, it would be great. So you will be basically interacting with the application. We will be voting on a very, very controversial topic.
Yeah, we need your help. We need to settle this once and for all.
Yeah, I'm a dog person.
Yeah, I'm a cat person, so and this morning, there was a lot of talks about dogs in the keynote stage, so I really want to bring, cats back. So let's see.
Can you access the application? Okay. Yes, everybody there? Okay,
yeah,
let's move.
Switch the application.
Let's take a look at the application. And you can see there, so we have the live dashboard there. Dogs and cats are being voted. We have here, the live results. I think that you need to refresh the middle one.
Yeah,
just
and
to see
it's raining cats and dogs, right?
Yeah. So if you refresh, you will see like the changes there. You can vote multiple times if you want to, so that should work. Or the internet connection is not working.
We're breaking it, yes.
That's the usual thing when you're building cloud-native stuff.
Yeah, too many votes for cats,
We will never know now, because I can see dogs and cats floating around. So that's kind of like what the application is doing. And how difficult it could be just to build this kind of applications, right? Like it shouldn't be that difficult. What are we doing? We are storing data in some databases. We are sending messages. We are consuming messages. It shouldn't be, difficult to build these kind of things. And by the opposite, it's like very, very hard. Like having teams to build complex versions of these applications doing very simple stuff. It's complicated. They will need to learn a lot about the infrastructure that they have available, and they will need to learn how to connect to all these different things. So
yeah, I'm sorry. It looks like cats are winning.
Cats are winning, and it's not moving. I'm surprised. Like after 10 votes, something is breaking there. We will just check it out.
Yeah, but distributed systems are complex, right?
Yeah. It's like eventual consistency. At some point, we'll figure out the result.
Eventually, yes.
eventually. You never know. Yeah. So let's go back and let's talk a little bit about where do we run this, right? But before that, let me introduce myself. So my name is Mauricio Salatino. I work for a company that's called Diagrid. I'm a software engineer. I've been building tools for developers for some time now. And I published last year this book titled Platform Engineering on Kubernetes. So I'm coming more from the YAML side of things. I like YAML in a way. But yeah, I've been working with Kubernetes for some time, and I've been working on some Kubernetes-related projects like Dapper, Knative, and Captain. I don't know if anybody knows about those projects, are much more related to Kubernetes. So if you are not working with Kubernetes every day, this might be a little bit strange to you, which is perfectly fine. As a developer, you shouldn't be thinking about this kind of thing.
Exactly. And myself, I'm Thomas Vitale. I work at Systematic in Denmark. I'm a software engineer there. I really am passionate about anything Java and cloud native. I combine these passions of mine and wrote a book recently. It's called Cloud Native Spring in Action with Spring Boot and Kubernetes. Also a big supporter of open source technologies, contributing to many projects, both in the Java ecosystem and in the cloud native space.
Yeah. And we have been working together for the last 2 years in kind of like that space, just combining Java and cloud native and kind of like figuring out how different projects works together, right?
Yeah, and getting all the advantages from cloud native technologies, but also keeping a really good developer experience. Like we don't want too much YAML or too much infrastructure.
That's our mission.
Yeah.
So, in general, where do you run these applications, right? And I think that I created a poll in the application asking how many people, is deploying these kind of applications in the cloud, right? I got a lot of responses saying, yes, we are deploying it in the cloud. And my next question would be, of course, after writing a book about Kubernetes, like, are you doing that with Kubernetes? How many Kubernetes people do we have here in the room? Okay. That's
a lot.
Yeah, that's kind of
60% of the room.
Yeah, and the other option might be something like, okay, maybe you are not using Kubernetes itself, but you are deploying on cloud providers, right? Like using Lambdas or using, containers or VMs or whatever, right? How many people here are using cloud providers, like on an everyday basis, where you're just using it, like constantly? You need to learn. Okay, so we have some folks here, and actually, it doesn't really matter which cloud provider, because no matter which one are you using, you will need to learn about it, right? So no matter which cloud provider are you using, you are probably using containers, right? And usually when we talk about containers, we talk about Docker. But for this presentation, and because I know that my friend here, Thomas, really like Open Container Initiative, that's the kind of containers that we are talking about here, right? So we are using containers, we are packaging our Spring Boot applications as a containers, and we are deploying them in a cloud native runtime that will run our containers. Most of the time when we run in Kubernetes or in a cloud provider, the container context doesn't have much for developers. It's just a way for us to package our application and to run it on the cloud. And containers are really, really helpful, right? Because as a developer, I can use containers to basically start Redis, start RabbitMQ, or whatever I need for my application, and I can connect to it, right? And if I'm packaging my applications as containers, I can create these complex setups using something like Docker Compose, or even like running all this stuff in a Kubernetes cluster to be able to test or to make sure that my application is doing what it's supposed to be doing. Test containers in that space, right? Like it's really useful, and it's very well integrated with the Spring Boot ecosystem. It's not the same for all the other ecosystems, right? So if you go to Go, they have some extensions there. If you go to C#, they have some extensions. But in the Java world, and with Spring Boot in particular, test containers is great for starting my Redis instances, my RabbitMQ containers, to actually write tests against these components.
Yeah, it's really a great time to be a Java and a Spring Boot developer.
If you have containers, and containers, right?
Test containers. Who's
good.
using test containers? Raise your hand.
It's good. We have it.
Yeah, it's an amazing project.
And for me, it was pretty good to work with the test container folks, because they know this community very well. So it's pretty natural just to do this kind of stuff. But for me, coming again from the Kubernetes side of things, when I look at Spring, I see these kind of things. I go deeper into what my Spring Boot application will need. So we have two things here. We have like common interfaces for dealing with data and common interfaces for dealing with messaging things, right? And then we have the specific clients for RabbitMQ and for Redis in this case. And that's the typical Spring Boot application, where we will just need to define our dependencies to make sure that we connect to this infrastructure. And it's okay when you're working locally because you have control of all the versions, but when you start moving this application across different environments, having control on which client do you have to connect to the production Redis instance gets a little bit more tricky and involves more teams than just developers. In Kubernetes, it's the same. It gets a little bit more complicated because you have like networks now, and maybe the Redis instances and the RabbitMQ instance is outside the cluster. So you need to make sure that not only you can connect to the IP address where the instance is running, but also you have the right connection properties on these clients, right? No matter what you're doing, you need to make sure that you connect to those instances in the right way with the right, thread pool and connection properties to make sure that the application will work in a production environment. And the problem, at least in my head, and coming from a different place, the problem becomes when you need to deploy your application on Google Cloud or AWS, and then you will need to start changing dependencies because now you are not interacting with Redis or RabbitMQ. You are interacting maybe with Google PubSub or Amazon SQS or SNS and different databases. So you will need to have different dependencies here. That becomes a little bit of a mess if you need to manage this application for working locally and working remotely on a cloud provider with managed services. It might not be a problem that you're facing, but it's a problem that some companies are facing. And I didn't change that, sorry about that. And then when you're working in Kubernetes, then you need to figure out all the client-side things on your applications, right? Like your applications to interact together, you will need circuit breakers, you will need some libraries to connect and fetch configurations from Vault or secrets, and then forget about like Sleuth that it's deprecated. Thomas told me about that, but imagine some kind of like client-side load balancing that you need to do. You will need to include some libraries to do that, right?
Yeah, and monitor the whole integration path across application, distributed tracing. That's one of the challenges that we have with distributed systems. Yeah. It's
good that Spring Boot, like now with Micrometer and all that stuff, we have observability out of the box. That's
across the entire landscape in Spring. So that's really, really great.
That's really, really good. That's something that before we used to do manually, right? So, and that's where Dapper comes in. Dapper, it's a Kubernetes project, right? And I will talk for 3 minutes about Dapper just to try to explain what it is. But the idea with Dapper is trying to delegate some of these concerns that I've been talking about, like connecting to infrastructure and building these resilient distributed applications, pushing it down to the, let's say to the infrastructure level, just closer to Kubernetes. That's why Dapper, that stands for Distributed Application Runtime, is like an extension to your Kubernetes clusters. So it's something that you install on a cluster. And if you're a Kubernetes person, you probably know how it works, right? Like you probably use Helm to install that into a cluster. And then when you deploy your application in there, you have your application, you have your infrastructure, like RabbitMQ or Redis, in this case, for this service. What you can do is actually annotate your application as this application will want to use Dapper. And what Dapper will do is will inject a sidecar, that's a separate container running very close to your application, that expose some APIs that the application can use to interact with it, right? And the sidecar itself, by reading some configurations in the environment, will connect to the available infrastructure, right? So it gets complicated, and I would say that sidecar is not a concept that you will use like if you are just building Spring Boot applications. It's not something that you see every day. But if you are in the Kubernetes world, that's something that a lot of projects does. But at the end of the day, what we want to do is we want to enable, delegate the responsibility of connecting with the infrastructure to a separate component, and let's make sure that the application doesn't concern much about it. The application just needs to consume some APIs. And if you can do that, actually, because now you have this abstraction here with these APIs that are exposed by the sidecar, you can actually start swapping out providers, right? Like you can just now jump into Google Cloud. Or just if you are deploying the same application into AWS, you don't need to change any code in the application because you are using the same APIs against that component. That's the whole point, right? And again, this is not for everyone, this is not for every use case, but there are some cases when having these abstractions make a lot of sense. Because you have this sidecar now, when you are connecting two services together, then you can start inspecting what is happening here, what APIs the application is calling, so you can have service discovery, you can have retries and circuit breakers built in there, so your application doesn't need to include any library to do that. And the same with security, logs, and observability, and all that stuff, right? Because now we manage the connection between these two things. The application, if this application wants to talk to that one, it will go here, and then this connection can be, using MTLS, for example, encryption. And all those things are now managed outside of the application, so the application is kind of like delegating control on all these things. The application is focusing on writing kind of like business logic. And again, if you're interacting with external services, you can use all these things to delegate that connection to the, to the Dapper component in this case. But
yeah, I'm not sure if I'm liking that because I mean, I'm a developer with Spring Boot. I have all these amazing abstractions, and maybe I don't have a problem. Like I already have amazing abstractions. So this seems to be
A little bit
very,
complicated.
a very good solution for Kubernetes folks,
Yep.
for the platform teams maybe. But let's see what we can do for
Just
for
to make
Spring
it
Boot
better.
developers.
Yeah, exactly. That's the thing, right? Like when I'm coming from a Kubernetes perspective, Kubernetes people is used to kind of like handle this kind of tools, but when you go to developers, you have like a pushback of saying, well, now the complexity has been shifted somewhere else, but I also need to know about that complexity. So that's not super nice. So what can we do? Kind of like what was the first thing that we did?
Yeah, let's figure it out. So
there is the next slide, right? Yeah.
yes, yeah, I'll show that in a second.
Yep.
Let's see. So I have a Spring Boot application.
Yeah. Can you see
All
that?
right.
Yeah. Can you see that in the back?
So you're saying if I want to, let's say, store some key value data,
Yep.
I'm not using Redis directly, but I'm using Dapper.
Yeah, exactly. That's the idea.
So maybe let's create a REST controller. Let's test it out. And we can get the Dapper client builder. So this is a common way of doing this. So we inject a builder, and then we can build a new instance of the Dapper client. Actually, I want there. All right. So
Just to clarify, that client is the access to the APIs that this sidecar component is exposing, right? So he's trying to create an instance of this thing that will connect to these APIs.
yeah, so with this client now, I don't need different clients to connect with different data sources, different services, configuration, vault. I
Yeah.
get one single entry point, right? All right. Yeah, let's give it a try. So let's make maybe a post request. We want to send some data, and I'm sorry, but you know,
Where is it going?
people spoke.
Yeah.
Cats won. So
For now.
for now,
Yeah.
let's have an emoji of a cat because you know, why not?
Why sending like text if we can send
Yeah,
emojis?
yeah. It's 2024. We work with emojis, right?
Yeah.
And then we have maybe the name of the cat. So we want to return a cat,
Yeah.
and we want to store it as a key value pair. So let's get from the request body a cat object like that. So what can we do? Let's see. We want to have request to, let's say, KV, key value pairs. And then now I can call the Dapper client. I can say saves state.
Yeah.
I'll give the name of the store that I want to connect to. So that's KV store. And I need to specify the key.
The key.
And we'll use emojis as keys, you know, in a data store because again,
Because why not? Like,
I mean, I can do it, so I'm gonna do it.
Let's do it.
And
Cat.
store the cat. But then we have to verify that it's stored
Yeah.
correctly, right? So I'm gonna get the state once again from the KV store, and I'm gonna use the ID, the emoji,
Yep.
like that.
And then the cat class. Yeah.
And I want serialize that.
I want a cat
I want.
block. And it's a reactive API, so you
yes.
can do async stuff and get value probably.
Oh yeah,
Yeah.
then we get the state
So you get metadata and
response,
stuff.
and
There
then we
you go.
get the value. Yeah, looks good.
Yeah.
Now I want to run it, but I don't have Dapper.
Yeah.
So do I have to install Kubernetes, install Dapper on it, configure the sidecar? Like
That's so.
that's not good. Like
yeah, it sounds like 2020.
yeah, we talked about test containers. We get so this great experience with dev services and test services in Spring Boot. So maybe we can do something about that. And actually, we can use test containers also for Dapper. So I don't have to worry about configuring different containers for RabbitMQ, for Redis, or whatever other service I want to integrate directly. But I just get this Dapper test container. And I don't need to know what's happening inside. I don't need to know how maybe in the platform team they're going to deploy a Dapper production ready setup with all the configuration and bindings. I can just focus on my business logic. So
kind of important, like in the diagram it shows HTTP or gRPC, right? Like, and what we are using here in the source code, it's like the Dapper kind of like client, like the Java client for it, right? We can actually go and write HTTP requests or gRPC, connect to gRPC to the sidecar, but in this case the SDK it's much easier, much faster. So let's
we are
use
using gRPC in this case.
Yep.
So just like we do for normal dev services, we have a test application in the test class path where we can define containers as bin. So we get a Dapper container as bin, and that's all I need. I can configure to have Dapper as like enable API for the key value store and for the pub sub that we're gonna look in a second how it works. But let's see. So does it work?
I don't know.
Let's run the application.
Let's try.
So
You never know. It's like a live demo, so it should fail.
So I want to store data in a key value store. I don't have any actual value store here, right?
Yeah. So
I'm using Dapper.
Can I import them there, right? Like the application that Thomas is running, it doesn't have a Redis dependency or a RabbitMQ dependency, right? Like it only has that Dapper dependency right now.
Yeah, and right now from the Dapper client, I'm just calling this Dapper service that runs in a container with test containers. So let's verify that it works. So we can submit on 8080 KV, and then we have the emoji. Let's pick a cat. Yeah, I'm sorry. It could have been a dog, but
it could be a dog, yeah.
Nope. Yeah, programming with emojis, has its downsides. Again,
it's just one. It's just one character.
It's just one character. Charm.
It's not two.
Yes.
There.
1, 2. Yay! Two. Name.
Yeah.
Tom, because why not? All right. So what happened here? We got the name of the cat, the emoji of the cat, but I'm not seeing the state.
That's interesting. Yes. Yeah. The live demos, right?
Yes.
Did you send maybe like a wrong character or something? Maybe you can print that you get the cat or something? Huh. You never know.
Yeah.
Yeah.
Let's have a look.
You need to block on the save. Yeah, there you go.
Yeah,
there you go.
Good.
Like,
the magic of reactive. Yes.
Reactive stuff.
I'm using DevTools, so live reload. I don't have to restart the application, and the container also doesn't restart because that would be wasteful. So great developer experience so far. It's just me having bugs in the code.
Yes. Yeah, exactly. And now it fails. Of course, the live reload. Yeah, there's a connection. I think that you need to restart it, unfortunately.
Okay, I spoke too soon.
That's good. That's
amazing.
Good. Like this is good because like we will just troubleshoot like while we.
Someone said if it doesn't fail, it's not a real demo because then demo, it might be recorded, right? So there it is.
Go. There you go. Easy.
We got the cat.
Now, if you go back to the diagram for a second,
yes,
before we go to the next one, I think that this is super important. Like the arrow here, it's bi-directional, right? It's not we are calling only APIs to the Dapper sidecar. The Dapper sidecar can call us back if we get messages asynchronously from other data sources, right? And that's what we are going to see now.
Yeah,
right?
That's important because the next part in our application that you saw earlier, one thing was storing these key value pairs in a state store, but we also want to exchange messages. So I'm not adding any RabbitMQ or other message broker dependency. I'm still using the same Dapper test container and Dapper client. So we can have another endpoint. Let's call it pubsub. And this time I'm going to remember to block because it's reactive.
Yeah.
And yeah, we can send another request body with a cat. And still using Dapper client.
Publish event. Yeah.
We can publish an event. So we'll give the name of the pubsub component, the name of the topic, cats, and we send the cat.
And you block.
All right.
There you go.
And yeah, actually, we don't need to return anything, right?
Yeah. It's kind of interesting, like publishing an event is that simple, right? Like if you want to publish an event, it doesn't really matter what infrastructure you have, you just do it like that. And if you want to consume one,
yeah, we're missing something, right? So here we are publishing messages. So how can we consume? Because you mentioned that we have this bidirectional exchange. So I'm going to use the same application, but what happens is that we can adopt a standard called cloud events. Cloud events can be exchanged over any kind of protocol. It's just a data exchange format, and you can actually use it to wrap a more specific data formats, like maybe an AMQP message or a Kafka message. It's just a convenient way to standardize the exchange format across any different type of data sources. So what we can do is actually exposing an endpoint. We have another post mapping. Let's call it subscribe. So this is how we subscribe to events. And we are getting actually a cloud event here. Using the cloud event Java SDK for a cat.
With a cat inside, yes.
Exactly. And once we receive the event, let's print it out and verify that we are getting the cat. We'll get the data. All right.
you're missing something there, right? You need to actually...
Yeah, we don't know what topic we want to subscribe to, right?
Exactly.
So that's
So we need
pretty
to
important.
Yeah. So we want to subscribe to a topic. You remember that you need the
And
pub
it's the
subname.
same name as this one.
Yep.
So we have the pub sub name, that's the pub sub component,
And then the topic name.
and the name.
Yep.
So we can already see there's a lot of configuration here that doesn't feel really natural, right?
Yeah.
Because I'm used to have auto configuration, I'm used to have application properties where I configure this type of information, and here I'm just duplicating too many things.
Yep, exactly.
But
But at least it's a little bit declarative, so you can get events, like publish
Yeah.
events and yeah.
And maybe it even works.
Maybe it works. Maybe. If
Yeah?
we blocked everywhere.
Yeah,
yes.
yeah, we blocked. Always block. When in doubt, block. All right.
So
So
you send a new cat, yeah?
pub sub 200. Okay, so we published a message.
Yep.
And we are getting down here. If you can see, we have cat emoji.
We have a thumb there in the terminal, right? So we just consume
Yeah.
that event.
Okay, so I'm less concerned now. It's a bit less worrisome. I don't have to deal with Kubernetes.
Yeah.
I don't even need to know what a sidecar was, because
Exactly.
that was a bit scary. Like,
What is it?
what's
yeah,
a
what the
sidecar?
hell? Yeah, exactly. And now, like, auto-wiring the Dapper client will give you kind of like quick access to the Dapper APIs with all the configurations for that to work. You know, test containers is starting a container there that you need to connect to, and all the connection strings and all the mapping between the container and your application is being handled by test containers
Yeah.
there.
So just to sum up, we have this Dapper client. We can auto-configure a builder, just like we do with REST client builder, or we saw this morning the chat client builder if you're using the great project Spring AI. We can define, we can call different services. We work with key value state store. We work with pub sub. And we're using test containers for running the whole thing using the Spring Boot dev service integration.
Exactly. And just to mention, this is not the only thing that Dapper can do. If like you do Dapper client dot, you can see that you can read configuration values from configuration stores. You can just get a bunch of secrets and a bunch of different things there.
Yeah.
So like there are more APIs than just the ones that we're showing here.
Yeah, but I think we can do better, right?
I think that we can do better, right? So while this is okay, what is that Dapper client? Why do I need to learn about it? Now you're pushing me to learn a new tool. So
Yeah.
can we make it a little bit more beautiful, right? Or
Yeah,
just
let's make it more beautiful.
closer to the things that Spring Boot developers already know, right? And what do we actually know, right? Like if you take a look at Spring Data, there is like this interface called key value operations that it's inside Spring Data key value, which is a set of abstractions to abstract key value stores, right? So if you want to use this with Redis, you can just use this interface that will have methods like insert, update, delete, find by ID, and send some queries and stuff like that. If you take a look at Spring Data key value, you will see that you can auto-wire a key value template, and then you can just start storing, objects. And you don't need to worry about the keys and all that stuff. It's going to be handled by the abstraction itself. So you can auto-wire a template, and you can start using that no matter which key value store that you have. And the Spring community is pretty good at creating these abstractions and providing a developer experience around it, right? If you look at messages, the thing that we also show, like exchanging asynchronous messages, you can find, Spring Kafka that gives you the same kind of like idea. You have the Kafka template, you auto-wire it in there, and then you start sending, messages with Kafka. And then you have the Kafka listener to just connect and wait for messages to arrive. It's a very declarative approach. You can see that you need to define the topic name where you want to, consume events from and all that stuff. So kind of like I know how to do that. It's pretty easy. It's pretty simple. I don't need to learn much about Kafka and how it works. I just use the template abstraction for that. Pulsar is the same. I don't know, people using Pulsar here? We have some people, perfect. We have a couple of people here, great. Same, exactly the same approach. It's pretty similar, so it's the same. And then you have RabbitMQ that has the weird convert and send method, but it's pretty much the same. You have a template that you can auto-wire, and you have a listener to just listen for events. Can we do something like that for Dapper?
Yeah.
That's the question. And I think that the question is, of course we can.
Yeah, so it feels more natural because then we can rely on these already well-known abstractions and programming patterns. So what can we do? So I'm not going to use the Dapper client directly anymore. I want to use something more abstracted away, maybe taking inspiration from Spring Data key value. So the first thing I can do for the key value use case, I can inject a Dapper key value template like that and auto-wire it. All right. So let's keep that. Let's create a copy and see how we can change that. So the first thing we want to do is getting rid of the Dapper client. So I can call the Dapper key value template. And in here we are inserting new data, so similar to how we would do with any other data integrations in the Spring ecosystem. And here in the insert, I need to store this data, but the framework, of course, needs to know what's the ID, what's the unique ID that we want to use for the key, so that we can also use it on retrieval. So again, using the Spring Data common way of doing this, we can add this ID annotation on the emoji, because why not using emojis as keys?
There you go.
All right. So now what we can do is providing the cat emoji as ID, and then the cat, and that's it. So I can actually get rid of all of that. So I don't even need to remember to call block. I love it.
Yep, that's good.
And then we can get it back. So we can say find by ID, and we use the emoji, and then we want the cat, right? And it's an optional, right?
It's an optional,
so
yes.
Let's assume that we're not going to get a null pointer exception.
Yes.
But even if we do, it's great. We're using Java 21. Since Java 17, we get the nice information when you get a null pointer exception. Finally, we got that you can see what is actually null.
Finally,
so no murder mystery party every time you get a null pointer exception, but you know exactly what is null. Anyway, so there's one more thing. So we are removing some of the hard-coded configuration. So again, Spring Boot style, we want to make it beautiful. So now the state store information is provided via configuration properties. So we can, for the state store, we can define the name of the state store we want to connect to. And that's it.
Kind of important to mention there, like you support like a default state store, but in Dapper, like with the Dapper APIs, the reason why you can specify a string in there is that you can have multiple stores basically pointing to different data sources. So if you want to move data around different stores, use the same APIs, but you connect to different stores.
Yeah, let's try again. And there it is.
Yeah.
So it works the same, but at least the programming style here feels more natural, and especially I don't have to remember to call block. That's the most important part.
That's the really important part.
Yeah, but maybe we can do the same for the pub/sub use case, because also down here we have a bunch of configuration that we might optimize a bit.
And we have the reactive stuff, but also like it would be nice to, like if you're working with Kafka already, it would be nice to have something pretty like similar to that. So we have the messaging template for that.
Okay, so I'll define a message template for Dapper for the cat resources. Let's auto-wire it, and we're gonna create a separate endpoint, pub/sub2. That's really creative naming. And now we can have the Dapper messaging template. So we can send it to the topic, cats, and the object. So that's much easier. And once again, we have the configuration for the pub/sub name in the application properties. So that's really nice. Let's try this. So we still keep the same subscription model, because again, it's really agnostic in compared to what we use to publish messages. It's listening to cloud events, which is a standard in the cloud native space, and that's it. So
the only difference, something that we were discussing at lunch, is that the only difference here is that you still need to expose like an endpoint, so Dapper, like the sidecar, can call you back into the application, but we can actually automate this and generate that endpoint like behind the covers instead of doing all that.
Yeah, we might make it even easier.
Simpler, yeah. Just like the Kafka listener, you just add a single annotation to a method, and then you just get everything that you need.
All right, let's go with pub/sub2. We get the 200, so we publish the message, and down there we get...
We have Tom again, and the cat with the key.
With the key.
Perfect. Yeah, that's pretty good.
Okay, this feels already better.
Yeah. And again, I just want to mention here that this integration is kind of like laying the groundwork of what we want to build. If you look into Spring Data, right, like you have the Spring Data key value that also provides like the repository abstractions on top of the template, right? So you can have like CRUD repositories built on top of this basic template functionality, and we are just going to add that functionality pretty soon. There are a bunch of other things that we can do around that just to make it simpler, but the main idea here for this presentation is to show how close we can get to the native like Spring developer experience. And for some teams, having this abstraction layer will make a lot of sense to standardize about how different teams do things. Remember that because we are exposing like an HTTP and gRPC endpoint, applications in any programming language can use the same APIs, right? It doesn't really matter which language are you using to connect to it. That for some companies, if you are a Java shop, that doesn't make any sense. But if you have like 20 different teams using building applications in different languages, having this unified abstraction can save you a lot of time.
Yeah, the important part about using cloud events is that you can listen to events published by different applications using not only different languages, but also not necessarily integrating with the same pub/sub model that you have. Like if you want to exchange messages through RabbitMQ, then all the parties need to know about RabbitMQ being integrated in RabbitMQ. But using the cloud event abstraction on top of that, then we enable more data sources to join into this distributed system.
Yeah, exactly.
Yeah.
But that's that's the start. I think that we can go and take a look into the slides.
Yeah, and just quick sum up then. So we introduced these two templates for key value store, for messaging template. We could do the same for other use cases. For example, we mentioned configuration. And then on top of that, what we'll probably look into is this higher level abstraction, because it would be really cool to have a Spring Data repository also based on this, and simplify even further listening to events. So you don't have to expose down here these HTTP endpoints, but just have a maybe Dapper listener, similar to what we use for Kafka, for RabbitMQ, or other technologies.
And then like thinking about like the new stuff that it's happening in the Spring community, all the clients, right? Like all the HTTP clients, the new kind of like new abstractions with the Fluent APIs. But there is more, right? Like of course you can do more stuff with Dapper, as I mentioned before. And there are two things that I wanted to mention for this presentation, right? Because we have a use case here when we receive a vote. Actually, the application doesn't want to do the two things, right? Like this is a common pattern that it's called outbox pattern, is that when you are storing a vote into Redis in this case, I want to also transactionally create a message in a message broker, in this case in RabbitMQ. And I want to do that transactionally. I want to make sure that if I manage to store the vote in Redis, I will generate that event. But if something fails when I'm storing the vote, I will not produce that event, right? And I want to be able to make sure that that happens. So what you can do with Dapper is actually enable the state store component that stores states into Redis to have this pattern enabled out of the box, so the application itself doesn't even need to send that event programmatically. Dapper will do it for you the moment that acknowledgement that the data has been stored happens. It's kind of like interesting to see, because now we have this pattern implemented. Doesn't matter the providers down there, right? Yeah,
but I think it makes a really good point about this, because RabbitMQ that we are using, now using directly RabbitMQ, we couldn't do this distributed transaction, because RabbitMQ doesn't provide support for that. So we would have to do some kind of custom logic around it to ensure the eventual consistency. But because we are using the outbox pattern supported by Dapper, then we actually can offload that concern to Dapper, even though the underlying technology, like Rabbit in this case, doesn't support that use case. So we always ensure that everything is done transactionally, both storing the state and publishing a message.
Exactly, yeah. And then you can go, of course, because again, we have these building blocks like key value stores, pub/subs, the outbox pattern is enabled there. We can start constructing more complex behaviors, like for example, durable executions and workflows, right? Workflows is a very common pattern where you just want to just run multiple services, like in a chain, in a sequence. And if something breaks, you want to be able to recover from when you were left off. And yeah, that's kind of like the kind of things that you want to do, right? Like if something fails, if I'm calling a service and it's like failing, I want to be able to automatically retry until that works. And for that, you will use retry, circuit breakers, and all that stuff. You want to be able to do like durable executions are called durable because they might happen over a long period of time. So you want to support like stateful interactions, right? I'm calling a service, I'm getting a response, then I need to wait for a person to provide an authorization, and that might take 2 weeks. And I want to make sure that the application is in the right state, waiting for that event, external event to arrive to move forward. And also to have that kind of like compensation logics. If something goes wrong, right, I'm creating a debit from my bank account, but something fails along the way of the things that I'm doing, I want to be able to provide a credit back with the money that I took from that account, right? Creating all these complex behaviors can be done by using these like workflow APIs that Dapper is providing. And we actually created a simple workflow to Raffle, one of the books that we have here, and you have some codes as well, right? The idea of this workflow is pretty simple, right? Like we have a database with all the votes. We want to pick a winner, like randomly go to all the votes, pick a winner, and then wait to see if the winner is in the audience. If the winner is in the audience, we will just give the book, and if the book is delivered to the person, then we will just save it in the database, right? We can do that. But it's kind of important there, when there's people involved in this process, you need to have some kind of like timers. Like at some point, it doesn't make any sense to wait for a person to show up anymore. So if nothing happens, it will go back and pick a different winner. It's kind of like interesting. We are still working on integrating that more natively with Spring Boot because there is no kind of like, I wouldn't say that there is no standard way of in Spring Boot to create workflows. We have Spring Boot like state machines. We are looking into some of that, but like there will be some abstractions around that, so the workflow functionality feels closer to Spring, and still kind of like work in progress there.
Yeah, let's Raffle.
Should we try to do that and see if that works? So if you still have the application, you should have your user ID on the top. And the first one,
this one.
Yeah. So if you still have that one, because I'm a dog person, and I can see people still voting. So let's do that. So basically, what I'm going to do here with this button here, I can make this bigger, right?
Yes, we can close this one, right?
Yeah, that is not working for some reason. Yeah, you can make that bigger, right? So what I will do here is I will just trigger the dog's workflow because I'm a dog person.
Okay.
So let's do it. You can do the cat one if you want.
Fine.
So I will trigger this. Drum rolls, please. And at some point, we should have a winner. There is the winner. Does someone has that code?
What happened?
What did you do?
I don't know.
There you go. Okay. It's the same code, right?
Yeah.
Does somebody has that code? Yes. So we have a winner. There you go.
Good.
Good stuff. So the winner is in the audience, and the winner will get the book because it's coming here. There you go. Thank you very much. Thomas, do you want to do a cat one?
Yeah, definitely.
Yeah, awesome. Enjoy.
So let's go with the
cat one.
Winner.
Drum rolls.
Drum rolls.
Maybe it's the same person. You never know. It's a different one, or is it the same? It's a different one, right?
Yeah.
Who has that? Check it. Okay,
all
there
right.
you go. Like people in the back, like they get lucky.
Yeah, let's talk afterwards for the book. Yes.
Yeah. You see, cat people. You see, you see.
No, I have a code to share with you to get the digital book. Yes.
Good stuff. Good stuff. That's good.
At we're still getting votes. Yeah.
The demo. Yeah, we're still getting votes, of course. We will count all the votes in the Redis.
Yeah, but it's too late. Like I think cats won.
You think that cats won?
Yes.
That's just not super convinced about it.
Yeah. All right, but we started with showing the demo, right?
Yes.
We are running, of course, in Kubernetes.
Yes, we are running on Google Cloud, right? Like again, we created a cluster and we deploy the application there. We install Dapper in that cluster, and it gets complicated.
Yeah. So we're running in Kubernetes, but again, what should I do as a developer? Well, not much different than what I usually do, actually. So I can containerize the application using cloud native build packs. And recently also we got support for ARM64. So it's getting GA, and thanks a lot, Dashaun, also, because thanks to Dashaun, actually, in the past couple of years, I managed to run cloud native build packs on my Apple Silicon computer, so thank you. We can do that. We can also build a native image with GraalVM. We're actually looking right now in some gRPC issue. So the Java library for gRPC is missing some GraalVM hints. So we're looking into that because we really want to, get a full native compilation. And what else? Then that's it, right, as the developers, because then expect the platform to take that application and run it in production, maybe in a serverless environment using Knative. We are actually using Knative so that we can get auto-scaling. So maybe we can have a look. We got some dashboards. Let's see how many votes you send. So there was some request volume, but how about the scaling? Maybe there were not enough requests. Yeah, I think our application is too robust for that.
Our application can handle a lot of requests per second, actually. And I think that's the main reason why we want to build like this native
it's still
images.
only one pod.
There's just a single pod.
Yeah, we should make it, a bit less efficient so that it scales. But then you get a cheap bill on Google Cloud, so
that's
it's fine.
Good. Yeah, please.
And what else? So I actually want to show you under the hood we're using RabbitMQ, so we can monitor RabbitMQ. Of course, the platform team has that responsibility because that's the underlying technology. Dapper by itself is not managing that publish-subscribe model. It's just the API on top of it, and then you can replace RabbitMQ with whatever service you want, either in the cloud or on premises. But this is just to show you this is RabbitMQ under the hood, actually. sharing messages.
It's pretty simple to switch from the RabbitMQ instance that we are using. We deployed RabbitMQ with Helm or something, with the operator or
Yeah,
something.
the RabbitMQ operator.
But it would be pretty easy to switch from the RabbitMQ instance to Google PubSub, that it's a managed service by Google, without changing the application at all. It's just a configuration file that we change, and then we will start using the managed service there.
Yeah, and we don't have to change the configuration on the Spring Boot application, because we'll always have that configuration to establish a connection to Dapper. But then we don't need to have credentials for RabbitMQ, for Redis, and other services that we might integrate with, because that's all managed at the platform level. That reduces a bit of complexity from the application setup, but can also be security also a benefit, because we don't have to expose this concern too broad.
Yeah.
All right. So one last thing. So we are showing these dashboards. Observability is a big concern. So one final step we also want to look more into is getting Micrometer supported natively inside the Dapper Java SDK, so that we can get even better insights into what is happening communicating with Dapper API. This is just to show you how we are deploying this. So locally we have this test container set up. We don't need to worry about anything related to Kubernetes or how Dapper works internally. But then when we go in production, for example on Kubernetes, then it's the platform team providing that environment that takes care of installing Dapper, configuring Dapper, and dealing with all those additional concerns to provide the right infrastructure. It could be RabbitMQ, it could be a service from AWS maybe. And the application is not aware of that. It doesn't have to know what is happening under the hood.
Perfect. If you're interested to learn more about it, that's the blog post, and you can of course reach out. And thank you very much, Thomas.
Yeah, thank you very much. We are still actively working on this, so if you tried out and you have feedback or suggestions, please reach out.
Yeah, if you want to contribute, of course, like this is a great opportunity to work basically with us, like on building this. So
yes.
Yeah.
Thank you.
Thank you. Right on time.